Good afternoon, everyone. I hope you can clearly hear me. It's 3:25, so we have 5 minutes buffer at the beginning, just to allow everyone to join this meeting about Energy Islands that is hosted jointly by CIGRE NGN Belgium and Denmark NGN. So as you can see, I'm Francesco Giacomo Puricelli, and I'm giving the opening remarks, and I will also be the speaker, let's say, that provides the question or that deliver the question during the question and answer time. Then we are gonna have first an overview on CIGRE Denmark NGN from Daniela Pagnani, that is the chair that just joined us from Denmark NGN. Then also another 5 minutes presentation, brief presentation from Giacomo Bastianel, that is the chair of CIGRE Belgium NGN. And then we will have the two main presentation of today's webinar on Energy Island from Yicheng Liao, that she's a power system engineer at Energinet, and from Nils Charels, that is a senior HVDC expert at Elia. These are basically the Danish and the Belgian TSOs. I will also repeat this later, but you can basically post your questions in the chat. And how we're gonna go about this is basically you are kindly asked to specify to which presenter the question is directed to, and then all the attendees can basically vote to the existing question, so that we can provide the priority to the most let's say relevant questions. In this way, the questions that are more relevant will be asked first, or that the people attendees that think that are more relevant will be asked first. I'm also posting this in the chat, so also the other attendees that will join later will be able to see it. So we can still wait a couple of minutes, since we are still ahead of time. And again, if you have any question, just as is written, please feel free to post it, and it will be asked according to availability and preference. Yes, the presentation will be shared, and the recordings we need to check with the CIGRE if it can be freely shared with all the participants, or will be provided on eCIGRE, or will be uploaded on eCIGRE. But in any case, if you're also CIGRE member, this will be available for free as well on there. We still have 1 minute, and then I will give the floor to Daniela for the presentation of the activities and the overview of CIGRE Denmark NGN. Then I will not interrupt the flow, and I will just give the mic to Giacomo Bastianel for CIGRE Belgium NGN. And then I will briefly introduce Yicheng Liao and then Nils Charels before the presentation, so that just to remind also the possibility that you have to ask questions and vote questions that are already present in the chat. Okay, I now will give the floor to Daniela, and we can officially start the webinar.
Thank you, Francesco. I hope you can see my screen.
Yes.
Perfect, thank you. So, as Francesco said, I'm here today just to give you a brief overview of CIGRE NGN Denmark. But first and foremost, my name is Daniela, and as said, I'm the chair of CIGRE DK NGN, as well as a power system engineer in Ørsted. I would like to start by giving you a welcome to the world of CIGRE. For the ones who don't know, CIGRE is a global community for the collaborative development of sharing of power systems. It's not for profit and has been over a century long in the world of electrical engineering specialized in power system. Has a long history as a key player and produces the main references and publications on the data. It's open, engaging, and fact-based culture. And this also for connecting power system professionals all over the world. CIGRE has 16 domains of work and each has a dedicated study committee. We have Group A based on equipment and the subcategories, Group B on technologies, Group C on systems, and Group D on new materials and IT. So for each of you with a different focus scope, there is for sure a part of CIGRE that can accommodate your expertise. So CIGRE is a community spread across more than 90 countries and underpinning 61 national committees, each offering members direct access to local events, services, and supports. And this is what we're doing here on LAN as a collaboration between Denmark and Belgium. Specifically, the NGN for you as a student or young professionals under the age of 35 is what will give you the getaway to the multi-phase world of CIGRE. Now, as a NGN member, we also have a steering committee. So we are the core team that makes events and other activities happen. And is formed of 8 people currently in Denmark. We're always open for volunteers. And here especially, I would like to give a special mention to Jacob, who was the one that helped me very much in this for this webinar to happen. As you can see, we have all different organizations as background, and we ourselves are split in different roles. We have sort of flexible roles at the moment with only me, Gustavo, and Leonard having fixed roles. But we are, let's say, handling every activity with enthusiasm and an open perspective. So if you want to hear more about it, just reach out to me. Part of the events is about, part of the NGN is about organizing event. We have 3 for the first half of this year. Soon we will have a physical event, a technical visit to Rumble Head Office and Energinet Transformer Substation. Then we will have in May a webinar in collaboration with CIGRE NGN Romania, where similar to here, we will have 1 speaker from Denmark and 1 speaker to Romania. And last but not least, we are also preparing the first NGN annual general meeting, where will be a hybrid event where we will have both introduction to the news from CIGRE Denmark and the NGN, but also 2 keynote speakers. And then the physical event is the one that kick off, is for refreshing and basically networking as this network of new generation. One of the parts of that is great about CIGRE is the several locations that there are for collaboration. There are symposia and there is the Paris session every even year, like this year. We will have the Paris session in August 2024, and there is a forum for different activities that you can see here. Our activities for the CIGRE Paris is, of course, the participation in the CIGRE NGN showcase. We have sent 4 members that, in case they are accepted, they will be part of this showcase and will also receive free registration. Moreover, we will also have soon to kick off the chance to give 2 NGN members the possibility to be an attendee to the conference completely for free. The announcement will be out soon, so stay tuned. More activities that are involving the NGN in Denmark is the participation to this Nordic Regional Council Symposium that there will be in Norway in 2025. We're planning for an NGN panel and NGN together with Women in Energy reception. So there is more details to come, but that will be announced later this year. So to conclude, this is the 9 ways to that CIGRE delivers value, but if you ask me, there is even more. And basically, it helps you be prepared for future key trends, innovation, and challenges. It helps you learn from real-world experiences, lessons, and successes. It informs about decisions. It helps you collaborate with other CIGRE organizations, like we're doing in this webinar. Can be the source to the most authoritative reference information, is unbiased, vendor-neutral, fact-based, and offer technical solutions. It helps you gain access at a nominal cost to the world-leading expertise. And actually, in the case that you're a student, even a PhD student, the CIGRE membership is for free. And help you grow as an individual and organizational skills, together with connecting you to the industry in a technical-based setting. So hope you will enjoy this webinar, and if you have any questions or suggestions, don't hesitate to contact me at the email address here. Thank you.
Okay, thanks Daniela for the introduction about the CIGRE and CIGRE NGN Denmark. I will quickly share my slides. And I believe that you can see my screen and also the slides. Yeah, I'm Giacomo Bastianel. I'm a PhD researcher for KU Leuven and HVDC, and I will briefly introduce the CIGRE Belgium NGN to you. Yeah, quick agenda. We have our mission and goals first, then the new steering committee that was elected a couple of weeks ago through just a votation. Then CIGRE BE NGN members that we have, some events that we had last year and we will have this year, and then our contacts. Starting from our mission and goals, we drafted, actually the founding members drafted a constitution, and essentially what we tried to convey as a message is that we wanted to form a network of younger professionals, but also academics, and we wanted to kind of connect these worlds to get the best out of both. And also we wanted to help other early career individuals to then grow their networks, but also their careers. Our goals, as you can see from the slides, is that we wanted to, just as said, help our early career individuals to grow personally, but also technically. We also wanted to connect to the CIGRE world as Daniela introduced. We are promoting activities, technical visits, tutorial workshops, but also webinars, as you may have imagined if you're here. We also have connections with other NGNs and decided that also with other countries. The current NGN groups, it's pretty well spread. As you can see, every year is growing with the different colors, and also we have some countries that are in development. I think there are 6, if I'm correct, groups joining this year, and you can see in this red circle that Belgium that was founded in 2022 officially. Our steering committee for this year, even though I said that we are trying to bridge the gap between academia and industry, is still academia-based, mainly KU Leuven-based. I am the chair. We luckily have Stan as our vice chair. He's more from a consultancy and power system group. Then Oscar Demanik as treasurers, and then you can see also among the participants, I believe, Oscar as the event lead and Francesco as also the moderator here. Our members they started in 2022 with, it was more university-based. We had a pretty massive amount of people from KU Leuven, but also from all other universities in Belgium, such as Leuven, Brussels, Ghent, Mons. And in the last year, we're pretty happy that we got an increase of 21 members from the industry, mainly from Elia, but also we saw a pretty diversified audience. This year, we will open the free registration soon, so please stay tuned in our LinkedIn page because we will announce it there. For the events that we had last year, we had a joint webinar with CIGRE NGN Netherlands, an event with CIGRE Belgium, in which, again, the idea of reconnecting academics with industry was thoroughly discussed, I would say, for the entire day. And then we had a presentation competition in which our winner, Eros Avdiai from KU Leuven, won free tickets for the CIGRE Paris session. For this year, we have this joint webinar with CIGRE NGN Denmark. We will have a joint webinar with CIGRE NGN Ireland, and then some technical visits will be announced soon. the idea is to touch different parts of Belgium with these visits. Plus, we will have a presentation competition as the last years in November. Last point is the connection with the CIGRE Award. We have a constant open call to submit articles to Electra magazine, but also we are collaborating with all the different working groups that are starting, and particularly for three working groups, we got 2 members from Elia, Grid International, and ENGIE joining the B4C497, Stan joining C1B449, and then I personally joined B498. So if you're interested in any of these working groups, please reach out to us. If you still haven't followed us, please scan the QR code and join our LinkedIn page. And if you have any questions, please contact us at cigrebngn@gmail.com. Okay, that was it.
Yeah, thanks, Daniel and Giacomo, for the 2 nice introduction of these 2 CIGRE NGNs. Now we'll pass the mic to Yicheng Liao, Power System Engineer at Energinet, for our presentation, Stabilities and Studies of Energy Island Systems. And again, just a quick remark, just feel free to ask the questions in the chat and vote, please, the questions that you feel that are more relevant for the ones that are already present, if any. Thanks.
Okay, then can you hear me and see the screen? Yeah, first of all, thanks for the nice introduction and the invitation to me to join this webinar. I'm Yicheng Liao, currently a power system engineer at Energinet. As you may know, Energinet is actually the Danish power system transmission system operator. Today, I'm going to give you a kind of a 20 minutes presentation on the stability and the studies for Energy Island type of system, because currently Denmark is also developing such type of systems. And to start, I will first give a short introduction. What is Energy Island? Maybe some of you have heard about that, but maybe some of you are not so familiar yet. And then I will introduce some of the design and stability challenge as the system operator we see are needed to investigate to design such kind of system, and what are the common study methodologies for power system operation we care and to do in such kind of project, and then followed by lastly some developer trend on this topic. And the Energy Island, Denmark is now developing 2 energy islands, one in the North Sea and another on the Baltic Sea. And the first target is also to integrate massive wind generation from the offshore, both targeting 3 gigawatts, but for the North Sea Energy Island, we also have the ambition in future to expand the generation and then interconnect such kind of energy island to also other neighboring countries or also another energy hubs. Then in the future, actually, we think that there can be plenty of energy island developed on the seas, and those energy hubs can interconnect from different hubs and also deliver the massive wind generation to the onshores. And the key to enable this is not only through the power transmission, but whenever we have those kind of massive wind generation, we also have the more flexibility to use the energy. For example, we can also convert into the hydrogen, enable some new form of energy resources. So this is the ambition. What is the typical way we can realize to build such kind of system from the electrical point of view? Then we rely on power electronics-based technologies. So this figure just to show you a kind of concept how this kind of energy island may look like. For the offshore side, we interconnect those wind energies through power electronics converters to deliver the AC alternating current energies, and through HVDC converters, we may convert those AC source to the DC power, and then we have the chance to deliver those energy to different onshore systems through different converters, and also perhaps in other energy island systems. So now the HVDC technology we discussed today for energy island is not the classical point to a connection. We are hoping to develop in some multi-terminal HVDC grid, and also together with this kind of energy concept, Perhaps we may also have kind of power to X facility connected to the Energinet, and also perhaps we need some grid forming, new technology, or perhaps energy storage solutions. So we are not sure, but there can be many open opportunity with this type of development. So we can see we have the ambition to integrate the wind fastly and also new technology, but for the system operation, power system, classically we mainly have the AC power system. We don't have so much experience how to operate such kind of DC system. So which means that we are lack of some functional specifications, not only for the grid, but also for these new technologies. This also makes it also difficult for all the developers and vendor staff to perform their design to develop such a system. This is just one point. Another point that if we look at this type of system, all different systems, they are actually interconnected through power electronics-based devices. This type of devices, they are very different. They have very different behavior compared with our classical synchronous generators, which are dominant in the classical AC systems. They are highly control-based, and also they are switching devices-based. So they can also introduce a wide range dynamics, harmonics to the power system. If not well designed, they can interact with each other more easily. And all these kind of power electronic-based devices, their control are very specific, and they can come from different OEMs and also different vendors, different developers. So considering such kind of 100% power electronics-based system connected under multi-vendor, multi-stakeholder environment, there is also kind of risk. It's not easy to direct connect. There might be interaction issues. That's why for the power system operator, when we design such kind of more complex system, we also need to ensure that we perform sufficient joint studies to resolve those interaction issues to make the project successful. Then to talk about how we do the studies on that, let's first look at how we typically design a single grid connection project. Let's take the HVDC system as an example. Usually the HVDC OEMs, they usually receive the requirement specification, and then they can perform the detailed design. And to connect the HVDC system to the power system, they also need to satisfy do a test to show the grid compliance. Then finally, if they are compliant, then they can start the operation. And also in this kind of classical project, those studies are most done standalone with their own OEMs. And if we talk about the wind power developer and also even other renewable source developer, it's quite also similar. The plant order, they receive the requirement, they find their OEMs, perform the detailed design, and then they show the grid compliance, then they start operating and connect to the system. But if we closely collect these two together, then their design can actually be highly dependent on each other because they just physically interconnected closely. So which means that to reduce the risk, we also need to perform some studies coordinated together. So then we need to handle multi-vendor, multi-stakeholder. It's more complex, not only it will cross TSOs, cross HVDC OEMs, wind developers, wind turbine OEMs, and so on, perhaps PTX. Then we need some studies. But what studies are usually necessary for system operator to consider? Here I will just show you some overview about what are the studies system operator usually perform. First of all, for the normal grid connection, we always require some phasor domain transient simulation model. And this type of model can ensure us to perform both static load flow calculation, which is very relevant for power system to consider planning, and also planning and operation. And also in addition with this type of model, we can also perform some dynamic simulations considering different grid contingencies. We can ensure that the power system is still stable and stably operated under different events. But also, these are quite classical power system study methods. We have also realized that power electronics basis, maybe those kind of studies are not so accurate to analyze all power electronics based interaction phenomena. But this type of study is still very relevant for energy analysis because one day we also need to integrate this kind of energy island system through HVDC connectors to connect to the onshore power system. We also need to evaluate the impact of energy island to the existing power system. So this phasor domain transient studies is also the basic studies for power system operation. And then, as I also mentioned, if phasor domain trend simulation is not accurate enough to review all the converter-induced interaction issues, we may need the electromagnetic transient simulations. And right now, those EMT simulation, they can done both using offline simulation tools and also real-time simulation tools. I would say many TSO and system operator and also developers and OEM, they have already developed some EMT offline EMT models in the detailed design of their project. But now, if considering this kind of multi-vendor, stakeholder environment, it's always running offline EMT model. Sometimes we are also not sure if we get sufficient accurate model representation using offline models or not. So now, right now, currently, real-time simulation is also kind of a new solution to addressing some issues, because a real-time simulation model, they can also interface with real control and protection replicas, which allows us to better represent the actual control behavior of the converter systems. This is one of the new solutions now also under development internationally. And also for power system operation, we also care about the harmonics in the system, because power electronics devices, they can introduce more harmonics if they are not well designed to damp those oscillations or in the higher frequency range. Then if the power quality and also harmonics are too large, then there will be risk to damage some hardware and equipment in power system. So we also receive some harmonic simulation models to do harmonic analysis. And last but not least, for power system stable operation, the small signal stability is also quite an important topic, because they are just the steady state stability. And when many power electronics devices are interconnected to each other, there could also be high risk for their control interactions. So small signal stability analysis can also provide more insight, especially if we have multi-vendor solutions interconnected with resulting some oscillation and interaction issues. This type of analysis tool can assist us to identify which is a major troublemaker, or which can also support us to more optimally design the entire system. And those last three study methods are also very highly relevant to the energy island application, not only to onshore, but also especially within energy island with this kind of 100% power electronic based system. But also, I would like to highlight, of course, if we just define one energy island, we know what devices we want to put and connect in the current system. But we remember that we still have the ambition to expand such kind of system for future connectives. Whenever perform these studies, make the models, we also need to think about if this kind of current study approach is still expandable, or can we maintain those models in future to connect the future systems. So this has already become quite a many challenge in many TSOs. We have challenges to use our current simulation models to do some system-wide studies, and also to investigate the interaction with new projects. Then I would just start from here to discuss three developer trends, I think, which are quite relevant for the energy island study topic. First, I also actually already introduced what are the commonly study method and could be the model which can be useful to perform the studies. For power system operation, to consider this kind of practical project, we cannot do the studies at the end after all the things are connected. We always need to specify some simulation model requirement first, and during the detailed design phase, we can do some studies based on simulation to identify the risks earlier, and develop the solutions earlier. So which means that we always require simulation models, but now we have already identified many challenges because all the vendors, they can come up with their own model. There have already been some model compatibility issues when we integrate those models to our power system model and to perform the system-wide studies. So this is actually an ongoing topic, especially when we consider using EMT models from power electronic systems more frequently now to investigate their dynamic behavior. To improve the model compatibility is important, and on the other hand, to ensure that those offline simulation models have adequately considered sufficient dynamics in the model to represent the correct behavior is also important. So this is why model verification to the offline models is also important. We need to improve our standardized understanding. What kind of test is necessary to ensure we receive the good quality of model that can really predict the real behavior of the device. And also the third point is about the model maintenance. This is also, we have also this kind of difficulty to use some old project models to suit the needs for future. So whenever we improve our model requirement, we also need to think about it. Can we receive some model which is still be able to run studies, for instance, in 10 years, 20 years with future models from future project. And we also need to use these models to handle our future grid expansion whenever we need to do studies. And this is about the model requirement. This is the prerequisite for us to perform the right studies. And then regarding the actual studies, because now we are not doing kind of standalone project with a single developer or a single OEM. We are considering multi-vendor, multi-stakeholder environment. We need to interconnect different models together to do studies. Then it is all the communication also becomes complex. So we need to have some common technical understanding what are the interaction phenomena to operate such kind of system. So all those kind of studies can be performed more efficiently. And also when we do some studies in the design phase, we find some interaction issues, there might be more study iterations required. So how to improve this study process is also very important. Last but not least, those model and studies, they are still technically. Last, I would also like to highlight for the system operator, we also need to strengthen the collaboration between different parties. So developing a multi-party collaboration framework is also very important. This also means that not only technically, but also legally, this is also very a kind of a challenge. We need to ensure we can get some models, but also those models and data can be shared across multiple parties in an efficient way to helping resolving the interaction issue, but still with respect to their own property rights. And then we also need to develop some joint interaction study framework to ensure that we can succeed such kind of multi-vendor project. And this is also an ongoing development internationally, and Energinet is also part of an EU project called Interopera. We handle both technically how to do studies, interaction studies, but also legally how we formulate this kind of framework to succeed. And so if any of you would like to further more of our development regarding Danish Energy Island, as well as other international consortium developing similar concepts, you are welcome to follow our developments through those links. And last, thanks for your attention, and any comments and questions, and I will come to be sent in the chat, and maybe we can discuss later at the end of this webinar. That's the stage. Yeah.
Thank you, Yicheng, for the very nice presentation, also to be very on time. It's always appreciated. So yeah, as she said, I would like to stress to post your question in the chat, and then to vote also the question presence if you also might have a similar question. So now, before going to the question and answer, we are going to have the second presentation. Second presentation is provided from Nils Charels, senior HVDC expert at Elia. And the presentation is titled System Design and Expandability of the Princess Elisabeth Energy Island. So thanks, first of all, Nils, for your availability, and the floor is yours.
Hi, thanks, Francesco. Can you hear me well? And can you see my screen?
Yes.
All right, perfect. Hi, good day, good afternoon, everybody. Thanks for giving the opportunity to give this presentation. And thanks, Yicheng, for the nice introduction on the energy islands and on challenges, studies, and challenges we see on energy islands in general. I'd like to now address more specifically a concrete project that we are, a concrete energy island project that we are developing in Belgium as Elia, so the Belgian transmission system operator, being our Princess Elisabeth Island, of which you can see a render there. I'd like to start first with explaining a bit the need on why we built the energy island. So we've seen in Yicheng's presentation this need of integrating and interconnecting integrating wind and interconnecting the various countries, and that's definitely a need we also see on our Princess Elisabeth Island. So if we first take a look at the development of offshore wind in Belgium, one of the things I think as Belgians, and I think the Danish as well, can be proud of, is that both of us were there already from the beginning of offshore wind. So we can see our first wind farms becoming operational already back in 2010, which is quite early on, I think, with the first of the world. We then had a couple more wind farms coming online, and then we see a first, for us, big step around 2010 with our first modular offshore grid, MOG1, coming online. And if we then look further to the future, towards 2032, we see that again we plan to take an increase of offshore wind production in Belgian waters, where we see an additional 3.5 gigawatt of wind that will be produced, wind energy that will be produced, and for which we need to have hosting capacity to bring that energy to shore. And so that is our first driver that we see. So this additional 3.5 gigawatt of hosting capacity that we need, and also that we need on a very concentrated spot, because that will be coming from one development zone. And then for the second driver, this interconnectivity, through the specific case of Belgium, I want to show why that is really important. So you can see Belgium on the map here. So for those that might not know Belgium very well, we are not the largest of countries. And for renewable energy production point of view, that has some consequences. We are also very densely populated, so we have a relatively high load compared to our surface. And our surface is going to limit the amount of onshore solar production we can have, the amount of onshore wind production we can have. And on top of that, we are also quite flat, so we don't have a lot of hydropower capability, combined with the relatively small share of the North Sea that is part of the Belgian exclusive economic zone. We come quickly to the conclusion that Belgium has renewable energy supply potential. So if we maximize everything that we can do in Belgium, we see that we have a deficit compared to what our economy will need when we transition to a full green economy. But luckily, as you can see, we are not the only ones. The orange countries on the map are all in the same boat. But luckily, there are also countries in our vicinity with an excess of renewable energy supply. And so this is where we see this need to interconnect the different countries, so that the countries that have excess capability of renewable energy sources can export those to the regions where there is too few of them. And so that for the Princess Elisabeth Island is clearly the second driver to start developing the project, so that we can in the end facilitate also this exchange between regions that are in renewable energy supply deficit to from regions that have an excess, and maybe not always in the same direction, because these things are volatile, so this can can change multiple times a day and certainly over longer periods. So those are our two drivers on why we think the energy island is the Princess Elisabeth Island is a good idea, and why we opted to go there. But having like good incentives to build is not only the only thing you need. You also need to have like the proper legislative framework to efficiently start developing those energy islands. And there, I think we also have a good case with this development of the wind in Belgium. We saw these first smaller parks. Back then, it was the developer that really was responsible to develop the wind farm, but also all of the infrastructure to bring the power to shore. And that's these cases you see at the edges, the first wind farms. In our first step that we did beginning of the 2020s or end of the 19th, there the legislation changed, and Elia, the Belgian system operator, already developed the first what we call electrical socket in the sea. So we built the first transmission level assets, providing an access point for the wind farms and already gaining in efficiency on the cables that bring the wind power to shore. So that is what we had in our previous wave of offshore development. Now with the second big wave, our legislator even gave us a larger mandate. So now we won't only be responsible for the socket at transmission level, but also for the step up from collector level voltage all the way up to 20 kV, which will have additional benefits in terms of providing resilience in case of outages and so forth. So in summary, the reason why we can develop our Princess Elisabeth Island is first because we have two drivers to needs, this 3.5 gigawatt of hosting capacity for offshore wind production, the interconnection facilities that we want to set up with our neighboring countries, and then the fact that we can legally also get the mandate to build all those assets. We're then going to look at what the system looks like that we want to develop. We have shown this here in a graphics schematic. We can see the Princess Elisabeth Island here. Again, stating with this first development that we will do is the island with the 3.5 gigawatt of offshore wind that will be developed by offshore wind developers, which will be connected using 666 kV as a collector grid voltage, because we estimate this to be the highest voltage that is sufficiently mature at the time frame of our energy island project. And we provide two transmission paths between the energy island and onshore in Belgium, being 6 AC cables, so 220 kV AC cables, because the distance is relatively short. It's about 60 kilometers. But in parallel with that, we'll also have a 5 to 5 kV HVDC bipole system. Reason we have the HVDC bipole system as well is because that then enables this second driver of providing these HVDC interconnections. The first one that is being developed jointly with National Grid is the Nautilus interconnector, so that will connect from the DC bus bar on the Princess Elisabeth Island towards the UK, and potentially also connecting intermediate to an offshore wind farm in UK waters. The second extension on the DC side, so for the DC hub, will be Triton Link, which is a project that we are developing jointly with Energinet, and which will link the energy islands in Denmark. So it integrates the offshore wind production as well to another onshore substation, a converter station in the Belgian network, passing via the Princess Elisabeth Island, so also allowing not only exchange with Belgium, but also between the UK and Denmark. So this is the high-level overview of the network that we're developing. We're now going to zoom in a bit on the single line of the Princess Elisabeth Island itself. Yeah, first of all, looking at the AC side, there we start to get into a little bit the advantages of why we are doing this as an island. And so looking at this from the AC side, the first thing that we'll see is that the way we've developed our AC single line diagram is really in a very modular approach. So the smallest building block of our single line is shown here now. So it's a connection of wind farm strings with a capacity of about 350 megawatts that are connected to our double bus bar 66 kV GIS substation, connected to a 3-winding step-up transformer, so twice 66 kV windings and a 220 kV winding, and then again connecting to 220 kV GIS substation. So that is our building block. But there we could now say, okay, we want to have 3.5 gigawatts. We just built 10 times an individual building block like this onshore that we bring to the island. Then we would have a lot of transport to the island to do, a lot of offshore works as well. So that is not efficient. We also don't want to just make one big module with 10 of these, because then it becomes too big to transport. And we also lose or increase the risk in case one thing would happen with that big module. Yeah, we would lose the 3.5 gigawatts. So there we did an optimization, and we came to two designs of AC modules that will be installed on the island. One design where we integrate 3 of these basic building blocks into a module with a total capacity of 1050 megawatts. And one design where we integrate twice the same building block into a module with then a capacity of 700 megawatts. And if we then look at how this looks in total to our island, we can see at the top we have twice this 1050 megawatt module connected to 3 AC 220 kV cables, bringing the 1050 megawatts in via AC to onshore. And then 2 modules with 700 megawatt of capacity connected to both of the poles of the HVDC bipole system, bringing then the power onshore via the AC system or via the DC system, and also injecting it into the DC network so that it can basically in the end go anywhere between Belgium, UK, Denmark. So this is the module design we have on the AC side. What you can also see is that between the modules, we have these connections as well. So basically giving us a double ring structure on 220 kV side. And this is again an advantage of the energy island, because all of the installations are close together. Linking them together via cables is also relatively inexpensive compared to otherwise if you would have to do using offshore platforms. And this is again an advantage because it vastly increases the resilience as well. So if you would have a failure on one cable or on one HVDC pole, via these links to the other modules on the island, we can still evacuate part of the power and maximizing the use of the capacity that is available, especially considering that offshore wind does not have a capacity factor of 100. So in most of the time, there is spare capacity available on these parallel assets that you can use. So that is the AC side single line. Here you can see that in an artist impression of what you're trying to build. So we can see the 2 orange boxes. Those are, the bigger one is the 1050 megawatt module housing the 366 kV GISs and the 220 kV GIS. The 700 megawatt is then the same, but only with 2 66 kV GISs. In between, we can see the power transformers, with again also the benefit that these are now outside of the modules. So from a fire risk point of view, this is also good for resilience, because in case of transformer fires, we don't lose the full module. And then, so this 2 we have at the far end of the island as well. And then in the middle, we can see all of the turquoise boxes, and those represent in the front our HVDC converter station, and then at the back our DC hub as well. And for now, can look at the single line of the DC. We actually see a second advantage appearing of the energy island, and that is that we can stage our development over time. So we have this ambition of linking MOG2 with Nautilus first in a single vendor fashion, and then with Triton in a multi-vendor fashion. To date, the technology is not there to do that. But if we are going to look at the development pace that we have in line, by 29, we want to have the energy island constructed together with the HVDC busbar with the point-to-point connection between the island and Belgium onshore to integrate part of the wind that is being produced. By 2030, we want to extend that in a multi-vendor fashion, in a single vendor fashion, with the connection of Nautilus. In 2032, we have the ambition to build the Triton interconnection, potentially of a different vendor. And we deem in 2032, with all the projects ongoing like Interopera, of having a multi-vendor HVDC system, we deem that to be quite challenging to date. But that's why in 32, we are not yet envisaging linking the two systems. However, by 2035, 2040, we think we can bring an additional module housing a DC circuit breaker and additional equipment to link both the MOG2 Nautilus system with the Triton system and to realize our DC hub. So this is the plan we have. The energy island allows to do that in an efficient manner as long as we have sufficient space and we take into account all of those different cable connections. So to date, to facilitate all of this, we sized the island taking into account conservative approaches of, for instance, the sizing of the DCCB, also of the sizing of the DC substation. So for instance, considering AIS technology, because this is what is available today. However, you see that certain of these developments will only have to take place more than a decade in the future. We are also expecting that technology will advance, things might get smaller as well. And so by ensuring the design of the island is capable of fitting the solution with the technology we know today, but not having to fix those things now, because the island gives some flexibility now, we expect that we will be able, when designing the Triton module, the DCCB module in the future, to gain some space and then allowing us to even use that space for potential other future expansions of the DC hub, being that integrating power to X or an additional interconnector. These are things that are still open. So all in all, yeah, we've seen the reasons why we are building the energy island. We've seen some of the advantages and yeah, summarize that here. So it is helping us really, we have to realize those ambitious goals of integrating in a small space the 3.5 gigawatt of hosting capacity in a reliable way, and also setting the first stepping stones towards this multi-terminal, most likely multi-vendor HVDC interconnected network. Next to that, it also allows us to design in an efficient manner using the same building blocks on various locations. And lastly, because we can split our modules into smaller parts that we can efficiently interconnect, and also we can segregate the fire risky transformers, we can do all of this in a resilient manner, ensuring also that if something happens, we do not jeopardize the stability of our onshore systems. So that was it from my side. Thanks for the opportunity to present.
Thank you very much, Nils, also for the very nice presentation, and also the being also for your side on time. So now we will open the question and answers. There are already quite a few questions in the chat. Please also continue to vote. We started to resume them in a PowerPoint, so that is also easier for all the attendees to follow them and also for the speakers. So I will start with the first question from Stein to Yicheng. And the question is, how do you see the division of responsibility for the mentioned interaction study between the TSO, HVDC converter, OEMs, developers of future connections, both in terms of performing the studies and determining the most suitable mitigation measures in case of interactions?
Yes, thanks for the question. To answer this shortly, I think the TSO's rules to ensure the system always operate stably, and those studies can be done sufficiently to ensure the stable operation. But because TSO are the one who start to design this system, but they are not the one who deliver the solution. So those HVDC vendor OEMs developers, they deliver the solutions to us. Then they need to deliver the models to us, and they are also the one who need to resolve the issues. So if the interaction issues are found, then we should still rely on them to deliver a solution to them. So that's why for TSOs, it's important to define what studies to be performed and what models can be received to ensure the studies can be performed. But then we also need to define the framework to ensure that the solutions can be resolved based on their design. So I think, does this answer your question?
Thanks, Yicheng, and also please also from Nils, but also the other way around. If you want to comment also on the question that maybe was not directly directed to yourself, please feel free to open the mic and just intervene. We had a question from Nils from Bernardo about the Triton Link and the Nautilus, if they will be in parallel from the Belgian energy islands into the mainland, or if they will be separated into different nodes in the Belgian main grid.
Yeah, so maybe Nautilus is the connection, onshore to UK, or from the island to UK, but yeah, I'm guessing you mean from the island in Belgium in the Mach2 first phase, and then with Triton. So those two HVDC links, they will arrive at different nodes of the Belgian onshore network. So they sort of will be in parallel, but they will arrive in different substations onshore. But Belgium is not so big, so electrically speaking, they will arrive basically at the same place.
Yeah, thanks, Nils. We have another question from Yicheng regarding the studies that will be performed to ensure interoperability. So is Energinet and the consortium developing the energy islands planning to utilize impedance-based methods for the small signal stability analysis of the energy island? Or I guess this question is also impedance-based or eigenvalue-based and so on.
I would say generally small signal analysis can be handled both by this impedance-based method or phase-based method. And impedance is just also one of the frequency domain analysis approach. For energy islands, the system design, if we start everything from known collaborator, then it's more easy to require more models to do studies. So I think both approach have pros and cons, but the most important thing is for us to understand which one is the right level to go, because we can always get sufficient models if we know everything. But the challenge is that for system operators, we cannot get white box models. And to which level is sufficient to resolve the issue most efficiently? This is still an open question, and we also need to learn through the project.
Thanks, Yicheng. So I think that indeed the key here is the availability of model, and also regarding to that, also understanding to which level it's let's say good enough. Okay, thanks. Then a question from Daniela that was directed to Yicheng in the first go, let's say, but I also took the liberty to also add Nils, since also he was talking about this during his presentation. So the question is, what are the advantages to build these large and complex projects such as energy islands instead of smaller and single wind farm and interconnectors?
Yeah, maybe I can start. Just to me, I think the most valuable thing is we increase the flexibility of the energy to use, like we can either connect to the onshore and also support the neighboring country, not only electricity, but if we have more and more renewable generation, we have more the opportunity to convert the electricity into other forms like hydrogen. Then there will also resolve some energy-related issues. And yes, so I think this is the flexibility for having this kind of new energy type of system.
Okay, yeah, and I also think look at it. I sort of see two things here. You say smaller single wind farms that are maybe directly connected to shore. And so there, I think if you have like these antenna connections, you have yeah, in case you have a failure on one cable and you only have one cable, then you're out. And an offshore cable repair, sadly, we are going through one to date. But luckily, it is also not on one of those antenna connections, and we have a parallel path. So the wind farm can still operate. Most of the time, it's not even being curtailed. So this is the advantage of connecting multiple wind farms on multiple cables. If they are, even if they are only, like you see, if you have 3.5 gigawatt on 3.5 gigawatt of cable, you could say, okay, I have no redundancy, but the wind is not blowing 100% of the time. So in 90 or in 60% of the time minimum, you will have sufficient capacity to not even need to curtail. I think this is one aspect. Then the second aspect is the combination of wind collection with interconnection, so what we call the hybrid interconnectors. And there, if you want to build a wind farm with HVDC and separately an interconnector, you have 4 converter stations. Whereas if you build a hybrid interconnector, you only have 3. And again, coming back to the utilization of that HVDC specifically for wind, because the wind has not a capacity of one, a capacity factor of 1, you will not really be properly utilizing that investment. And so the utilization that we see from a hybrid interconnector is a lot better. So you're using the investment you made in a better way. And that's also something which is going to be crucial. The resources that we have, not only in terms of money, but also in terms of amount of installations that the industry can deliver, is limited. So we need to find the most optimal way to use those.
Thanks to both for your answers. We have another question for Nils from Gustavo. So if will you operate the 2 poles of the bipole in parallel, or the AC interconnectors between them is normally open? And besides, since there is an AC connection to onshore grid, will the offshore HVDC converter operated in grid following mode?
Yeah. So yeah, it's the standard way of operating such an HVDC is not connected in parallel with an AC line. Because most of the cases you don't have both coexisting at the same. I think we have a specific business case where this is, or a project where this is the case. We do see an added value of linking the 6 AC cables to the converter station onto one electrical node. And so it's our ambition to develop this and to go together with the HVDC vendor to explore how we can develop the control system in such a way that we achieve this, what we call single node operation, whilst still naturally ensuring stable operation of the complete system. And that's the most important thing. So that is operating the HVDC in parallel with the AC cables. If we look at the bipole when it's not connected in parallel with the AC cable, there is indeed the options to either keep both of the poles separated, with the advantage that they become more independent, but with the disadvantage that you would lose always half of the capacity in case of a fault, even if you are not exceeding the capability of one pole. And so there we are exploring together with the vendors, because whether it's possible to guarantee stable operation, even in case of fault and temporary overloading of one converter, when both of them are connected together. And so if this is stable in a feasible way, this is also what we would go for, but we always have the backup standard solution to just keep both of the poles separated and also not in parallel with the AC cables, should these developments be turn out to be too complicated.
Okay, thanks, Nils, for your answer. Always for Nils from Germano. There was a question regarding the responsibility of the stability of the 66 kilovolts grid. So it was from Elia or from the wind farm operator?
Yeah, I think here I'd like maybe to also link back a bit to the first question that was asked to Yicheng, because in the end, and to her presentation as well, the stability to ensure this is exactly this sort of this question between the development of the HVDC system and the development of the wind farm, and we will have to coordinate. And to allow this coordination, there will be input required from the wind farm operators that are developing the wind project, and there will be information required from Elia. Now, how the details of those exchanges sit, that's like conformity processes and grid connections, etc. That's all being developed as we speak as well. So Elia did a public consultation to also collect the input of the different stakeholders here, but it is clear that it will not be so responsible of one or the other.
Okay, thanks for your answer, Nils. We have a question from Arwin that was already answered in the chat, but maybe we can propose it again. So from Yicheng, if the wind turbine converters,
Yeah, maybe I can just answer shortly. Personally, I don't know if a wind turbine converter today is mature to deliver grid forming functionality or not, but of course, there have already been developed in the wind industry regarding the grid forming functionality from wind power plant. But today, still the mature solution is still grid following. Yeah, this is how I know from today.
Yeah, thank you. I see that we are 2 minutes over 10, but if you are okay with that, we can continue to answer a few questions still. From Oscar, he was asking to Nils, is the integration of shore floating PV system considered as an option beyond 2030? And if the technology is young but likely easier to scale than wave tidal system and developing fast?
Yeah, so regarding the integration, so whether it's being considered as or not, I don't really know, because there is more than just the electrical system there, and there is also marine spatial planning to allow the floating PV, etc. But from an energy island point of view, we do consider some expandability for future uses, whether that is for floating PV or for other things. That is things still to be investigated, but definitely not just excluded.
Thanks for your answer. And then from Daniela to Nils, will the POI of the offshore wind farm with the energy island be at 2020 kV? Why not at 380 or 400 kV?
Yeah, there also in the framework of the first Mach1 project, but also elsewhere, we see that in AC often 220 kV turns out to be beneficial. And so there it's a balance on size of the installations, reactive power generated by the cables, and transmission capacity. And I haven't been involved in the I haven't been involved in those studies, but apparently that is turned out to be economically the best solution, the 220 there. And maybe just on a point of interface point of view, the point of interface here is on the 66 kV side for us.
Yeah, thanks. I saw also that was raised the same point also in the chat. So thanks also for answering there. We have a question from Mario that I reported here. From Nils. So have you considered energy storage for addressing stability issues, curtailment, and auxiliary services? And energy islands would have enough space for further deployment of energy storage systems.
So I think there, energy islands, the surface still is not cheap. So there is still definitely a cost associated to that. So if you're purely thinking about energy storage just for the sake of energy storage, I think the business case for onshore storage compared to offshore storage will be quite favorable for onshore storage. And I also see a question related to stability, and there it is indeed one of the challenges with energy islands is the fact that you have no load, you have almost no damping. Some type of storage could help there, but we ran some simulations and it showed in our case that it should be feasible to develop the energy island without having these either energy absorption devices or energy storage devices installed offshore. And so there it's purely also a cost benefit. We do have some synchronous condensers onshore for stability reasons. But yeah, it's a lot cheaper to install things onshore than offshore, so we don't do it if it's not necessary. Yeah.
Thank you for your answer. We got a question from Francesco to Yicheng, I believe. So how is the frequency range of interest determined for our harmonic studies, but also Nils, if you want to comment on
maybe I can just, I cannot recall the exact value for current Danish power systems harmonic model requirement, but you can check it. Actually, there are public information for HVDC and also RFG. Then you will find those requirements from our website for the harmonic model requirement.
Okay, I think so. It's basically referring to the standards that are present, right?
Yes, I think there are some kilohertz, but I cannot remember the exact value.
Okay, thank you. So a question from Joseph that is directed to Nils. So what is the estimated physical size footprint of the island?
So the island itself has a usable area of 5 hectares. I don't know the length and the width by heart, but it's 5 hectares. It's not too small.
Yeah, indeed. Okay, thanks for your answer.
A colleague sent it to me. It's 500 by 300 meters.
Okay. Okay. Thanks also for the precise measures. So a question to Yicheng, always from Joseph, is asking, we see RMS models having some difficulties under low short circuit conditions. How do you see the future of RMS simulations compared to MT simulations, for example?
Yeah, according to Danish power system study experience, normally in weak grid scenario and also in the area with high penetration of power electronics based system, we need the EMT studies. Yeah, so usually we'll do some pre-screening about the system condition and then decide if we need the EMT or not.
Okay, so first a pre-screening with EMT and then a decision.
Yes.
Okay, thanks a lot for the answer. I think we covered all the questions present in the chats, if I'm not mistaken. Otherwise, please feel free also to send a reminder. And as was also said by our speakers, you are free also to reach them to the contact that they left in the presentation, both from Yicheng and Nils, but also Daniela and Giacomo if you had more questions related to the NGNs. So we will distribute the slides after in the next days after we close this webinar. So I would like again to thank both Nils and Yicheng for their availability, and also for the 2 NGNs also to let's say provide this platform and organize this webinar. We see raised hands, I think. Okay, it seems that it disappeared. So maybe we can just close the webinar, and please feel free to reach out again to the speakers if you have any additional question. Thank you again.
Thank you all.
Thank you all.
Thanks everyone for
Bye.
attending. Have a nice
Bye.
day.
You too.